notes while I'm doing that. Are there any questions, comments, concerns before we get it going today? Everybody get a job fair?
Yep.
Yep.
We applied.
Everybody go to the job fair? Virtually? Was it weird? A little bit?
It wasn't necessarily weird, it was just like complicated. Because sometimes the computer won't work, or you couldn't figure out how to turn the video right or something.
Yeah. All right, let's see. A little bit of housekeeping. What's today? Wednesday? Almost was like, how was the weekend? But you know, it's Wednesday. Something's due tonight, right? Yes, assignment number 4 is due tonight. And then the first exam is ready. It's locked and loaded. It's on Blackboard. Not for you, but it is technically there. It's hiding. I've got it set up to drop on Monday at 8 o'clock in the morning, and we'll do that Wednesday at midnight. So you get 3 full days to work on.
How long is it?
It is shorter than the self-study assignments.
Shorter than something? Okay.
Yeah.
3 days to finish that.
It took me about 45 minutes.
To finish it?
Yeah. And so the rule of thumb is, right, however long it takes me, I always sort of like multiply by 3, right? So it takes me an hour to finish it, and I expect it'll take you guys about 3 hours to finish it.
Yeah.
That's a good sort of rule of thumb for timing it down. So I don't expect it to take you guys more than 2 or 3 hours.
Okay, awesome.
So, and it's a take-home exam, so. Any questions about that? So yeah, do Monday. What's really gonna bite some people in the butt is Wednesday, there will be 2 things due at midnight.
Assignment 5?
The assignment 5 will be due, because we're gonna finish this unit 5 today, which means the assignment 5 will be due Wednesday at midnight, and the first exam will also be due Wednesday at midnight. So be aware of that and manage your time accordingly.
Finish assignment 5 before.
So get assignment 5 done like this week, so you can focus on the first exam for next week. Okay? Any questions about that? All right, cool. In that case, what were we talking about last night?
The Karnaugh Map.
What about Karnaugh maps? So we talked about specifically 2 of 3 variable Karnaugh maps. Are there any questions about those Karnaugh maps? Right? Hopefully you find it to be a lot easier than doing the Boolean algebra, because I don't know, I think it's a lot easier to kind of just draw it out and look at it and visually see what the minimal solutions are. Today we're going to wrap things up. We're going to talk about 4 variables. Karnaugh maps. The textbook has a section on 5 variable Karnaugh maps. We're not going to do them because they're crazy. They involve drawing cubes. If you want to come talk about them in my office hours, I'd be happy to do that. But we're not going to spend any class time on it. So don't worry or stress out about 5 variable maps. That's just too much drawing. So the same. Let's say this. For a Boolean expression of 4 variables, let's get a little definition going. Variables. The same rules of adjacency apply. Adjacency. And what do I mean by that? What does it mean for 2 terms to be adjacent to one another? Another way to ask that is, when can we combine 2 terms?
When they're different by 1.
Say it louder.
They're different by like 1.
Exactly, when they're different by 1 bit. When we do that binary notation, if there's 1 bit difference, then they'll combine. So for example, if I look at, what do I have here, min-term 5 or min-term 1, right? 5 is 0, 1, 0, 1, or 0, 0, 0, 1, right? We look and see, well, what's the different term? It's this one, in the second left position here. And so what is that going to combine to?
Does it eliminate?
What's that?
Does it eliminate?
That combines.
Oh, combine. Yeah, right.
So we did on Friday. What you got?
Like 0 dash 0 1.
Exactly, right? So everything that's the same stays the same. The things that were different, the bit that was different, gets eliminated. So we're going to have 0 dash 0 1, exactly what it said. Now, if we were to flip that over into Boolean algebra, 0 1 0 1, we're dealing with 4 variables. So that's going to be what? A prime, B, C prime, D, or A prime, B prime, C prime, and D. Now that is going to simplify to what? What is 0 dash 0 1 in Boolean?
A on C on D.
Exactly. A prime, there is no B. C prime, and D. Good. Any questions about that? Because like I said, that's what we're going to be doing with the K-maps. We're just going to be doing it graphically. The rules for setting it up are the same. So first, let's talk about the structure. Of a 4-variable map. All right. Start off with our given a Boolean function of 4 variables. Call it F, A, B, C, and D. The map is going to look like this. So 2 variable was a little box, 3 variable is a big rectangle, 4 variable is a big box. Draw a big square. Cut it in half, or cut it in quarters, I guess, horizontally, then cut it in quarters vertically, just like that. Same deal, we'll throw the stem on the edge there. That's convenient. Draw the F on the stem. On the top side, we'll have A and B. On the bottom side of the stem, we'll have C and D. We'll label the left-hand side in exactly the same way we did for the 2-variable map. So 0 0, 0 1, 1 0, 1 1. And then we'll do the top side in exactly the same way. We'll do 0 0, 0 1, 1 1, and 1 0. Remember that we go 0 1. Oop, I screwed this one up. I can't even say it's Monday. 1 1, 1 0. So remember, we go 0 1 3 2 because of those adjacency rules, right? For these cells to be next to each other, they can only differ by 1 bit. So that's the setup. To make things a little bit easier for myself, and I recommend you guys do the same, I always label the boxes just with the min-term numbers themselves, right? So 0 0 0 0 is 0. And the way the count works, it's 0 1 3 2 in the first column. The second column is 4 5 7 6. Now we'll skip the third column, go straight to the fourth column for 8 9 10 8 9 11 and 10. And then finally here we'll go 12 13 15 and 14. Any questions about the setup? All right, let's start working with it. Let me erase this. thing I'm gonna do is just draw a larger map. It'll be easier to play with. Okay, so we've got an empty map to work with. The first thing I want to do is, last time we did that reverse engineering problem where we sort of started with the function and then filled in the blanks. I want to start with that here with this map. So with this example, we'll say, plot the given Boolean function. What we got is that f, the function of a, b, c, and d is equal to a, c, d, actually we do it this way, equal to a, c, d, or a prime, b, or d prime. Trying to write a little bigger for the folks watching on the stream. Okay, so what we're going to do is we're going to take this function, which has already been optimized, and sort of map it, reverse engineer it back on to the map. Let's start with the easiest one. D prime, presence of this term D prime. Oop, actually we need to set up the map here first. Remember we got F, we got A, B, we got C and D. So now the presence of D prime is going to do what for us on the map?
It's one on the top and bottom row.
What's that?
It's one on the top and bottom row.
One on the top and bottom row, you're absolutely right. Yeah, so we're looking for the places where it's just D equals 0, we don't care anything about anything else. So that's just going to be 1, 1, 1, 1, 1, 1, 1, 1. Now that points out an important fact, which is that the tops and bottoms are adjacent to each other. So this term here, 1, 1, 0, 0, and this one is going to be 1, 1, 1, 0. Do they have one bit in difference? They sure do, right? So they're adjacent. So this means that we can combine across the top and bottom. All right. What about A prime and B?
The second column.
Say that again?
The second column.
The second column, right? A prime and B means we're looking for A equals 0, B equals 1. Yeah, which is right here. We don't care about anything else, so we've already got a term there, so we don't need to put it again. And we flush out the rest of the column. Very good. All right. A, C, and D. Good, well done. 15 and 11. And that's because C and D are both 1, so we're going to be looking in the C and D's 1 and 1 row, and then where A is equal to 1, which is going to be the second and third. So yeah, 15 and 11. Outstanding. And there we go. So we've taken a function that was already optimized, we've mapped it back on to our map. Any questions about that? Are you freaked out by the fact that we're not doing the like the variable labels on the outside?
Yes.
It freaked me out at first too. So the old textbook had a different way of drawing the map.
That makes more sense.
What's that?
It makes more
It does.
sense.
It doesn't. It doesn't. I thought the same thing when I started working with this map, and then after I got used, I like this one more now.
No.
You'll learn to love it. It's good. I don't know, something about like having to what it did was it labeled everything. So here you would actually just mark this one as D and C naught, D naught, and D naught, like so on and so forth. So you just like read the variables on the outsides, which sounds cooler on the surface, but I don't know. After a couple hours working with this, I was like, nah, dude.
It took me a hot minute to figure out what was going on when I watched Friday's video.
I almost wavered when I was writing that lecture. I was like, you know what, maybe I'll just go back to the old way. But I didn't, and I'm glad I didn't. Because like, I don't know, something about working with, like thinking critically about the rows, just like, I don't know, makes your brain work a little harder, and it makes it a little easier to comprehend. I know all you guys are like, man, can we just do the one that has the labels? It's better this way. This will make you stronger. All right, let's do another example. Here, what we're going to do is we're going to say that f is also a function of a, b, c, d. And here it's equal to the sum of minterms 1, 3, 4, 5, 10, 12, and 13. Okay, so now all we do is we go and we put ones wherever it says their minterms are. So let's see. So 0, 0, 1, 3, 0, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we put ones at all the cells listed as minterms, and we put zeros at all the other terms. And the game here is exactly the same as it was for the 2-variable map and for the 3-variable map. We make the largest, the smallest collection of the largest groups possible. And remember, they have to be rectangles, and they have to be sizes that are powers of 2. So, where do we go?
Big box number.
What's that?
4, 8, 5, 4, 12, 5, 13.
4, 12, 5, 13. Figures of 4. That's totally right. So what is that going to get us?
C naught B.
What's that?
C naught B.
Yeah, so it's in the C
Or
prime.
B C naught.
Yeah, I mean, there's no like rule that says you have to write them in alphabetical order. Everyone does, just because like it makes like intuitive sense. I mean, so saying like C prime B is totally a valid thing. Remember, we're not going to do that because it's crazy. Yeah. So it's in the C equals 0. The top 2 rows are C equals 0, splitting the 0 and the 1 on the D, splitting the 0 and the 1 on the A, but A, B, 0 is equal to 1. So that's going to be B and C prime. What else we got? Yeah, 1 and 3, and then 10 by itself. We got this one for all of them. Yeah, so we'll talk about 1 and 3 first. So that's definitely in the A equals 0, B equals 0 column. And then it's hanging out with D equals 1, but it splits to C. So that's going to get us what?
Oh, A not B.
Okay. Not just A not B. Wait, hold on. Yeah.
A not B not, sorry.
And not just A not B not.
Oh my God. D.
Good. A not B not. And D. Good. All right. And then finally, yeah, she said 10. It's down here by itself. Yeah, sometimes just lonely, right? It's got nothing. So that's just going to be the entire minterm for 10, right? It's going to be A, B not, C, D. Any questions about that? Today we're just going to blast through a bunch of examples to work in this game. let's get set up in the next one. What is it asking at this point? All right, another example in exactly the same way. We're going to say that f is equal to the sum of minterms 0, 2, 3, 5, 6, 7, 8, a bunch of 10. And then we're going to have room 11, 14, and 15. So let's see, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What you got?
So you're just putting ones if it's like in the midterm expansion?
Yeah, it's listed in the midterm expansion, it gets a 1. If it's not listed, it gets 0. While you guys are working on that, Tam on Discord asks, will homework 5 still be due next Wednesday? Yes, homework 5 will still be due next Wednesday. So make sure you're managing your time appropriately between that and take-home exam number 1. What you got?
Would it be productive? Because 8 is also exponent of 2, or power of 2. So would it be productive to just take that whole bottom set?
You bet it would be, man. Yeah.
Even
Yeah,
if
so
it
remember,
was-
so it's rectangle, it's power of 2 because it's 8. So yeah. So you're saying let's build one big monster group. And this block of 8. So what is that going to get us?
C.
Yeah, just C. Because it sits inside C equals 1, split everything else. All right, having to think of the variables as 1s and 0s is why this method is better.
You also go down instead of
It also flips on its side too, yeah. So it's,
That's what really trips me
yeah,
up,
freaking out too.
is trying to count down instead of across, because I'm used to, yeah, that's wild.
So what else can we do with this guy?
For the rest of them, would you just have to take each one individually?
No, you don't have to actually. Well,
Do 0 and 8.
what's that?
0 and 8.
So we can do better than 0 and 8 though. What can we do? In addition to just, so it's going to involve 0 and 8 for sure. But can we do it better?
Could you combine 0 and 2 still?
Yeah.
That's what you think.
And if you combine 0, you can also combine 8 and 10. So the 0 one is 0, 0, 0, 0. The 2 one is, actually not 2, it's 0, 0, 1, 0. So those guys combine. The 8, 1, 0, 0, 0. And the 10, 1, 0, 1, 0 also combine. Which means we can what?
Can we do a box with them?
What's up?
Can we do like a?
You can do a box in the corner. This is, documentor says this is the most important detail in all of this course. Every time I bring up K-maps, he always says, don't forget to show them that you can combine the corners in a 4 variable K-map. Yeah. So you can do 4 corners. Which will get us what? Good, B naught. And B naught.
And then you usually the 5 alone.
We don't have to.
5 and 7.
5 and 7, right? So we can do 5 and 7. Now, why can't we do 5, 7, 6?
It's not
power
Because
two.
it's got to be a power of 2, right? So yeah, but so we don't need to do it by itself, and we can at least combine it with 7, and that's going to get us what?
A not BD.
A naught, B, and D. Good. A prime, B, and D. There we go. Any questions about that? All right, see you next one.
Next one.
So now we got a couple of basic ones under our belt. Well, actually, I think we're going to get done a little early today. Which never happens. Let's talk about a few kind of quirks or interesting details. All right. So I'm going to say that our function of A, B, C, and D is equal to the sum of midterms. 1, 3, 5, 7, 9. Or the sum of don't cares. 6, 12, and 13. Remember that the don't cares are the ones that we could make them zeros or 1 depending on what was convenient. So when we go to plot this, we will go, let's see. 0, 1, 0, 1, 0, 1, don't care, 1, 0, 1, 0, 0, don't care, 0, 0. K-map is where the don't cares really shine. Because before, you can choose to use them or not use them. In Boolean algebra, you had to check. You had to actually like, if we make this 0, what's going to happen? If we make this 1, what's going to happen? Here, you can choose to use them on the map or not use them. So, what do we want to do this guy?
Can we do a box and then a line?
A box and then a line.
Box of 1537 and a line of 1539.
Good. One box at 1537. So that's a box here of 4 around these terms. And that's going to get us what?
A not D.
Good. A naught and D. And then, yeah, we can make a row here at 0, 1 because we can include this don't care, which lets us create a group of 4. And that's going to get us what?
C not D.
C naught and D. All right. Are we done?
just staring at the board.
Maybe. Yeah, we're done, right? As long as we've covered all the min terms, or as long as we've grouped all the ones, it's all good, right? We used this don't care because it was convenient to let us create a larger group, which gave us a smaller term. But these two guys are the ones that we can just say, well, those are 0, and we don't need to use them. You only use, like I said, the K-map is where the don't care really shines because it's really easy to look at and be like, yeah, I'd like to use this one and make a group of 4, but I'm going to ignore these other two because they don't matter. Cool? All right. All right, one last example. We're going to get extra weird.
Are you supposed to use Karnaugh Maps for homework 4?
No, you're supposed to stick to Boolean algebra for 4. And that's a really good point. She asked, are we supposed to use Karnaugh Maps for 4? No, you're supposed to use Boolean algebra. And there are going to be problems on 4 where you're going to really wish you could just use K-map. But no, you still got to use the Boolean algebra on 4. You're not allowed to use K-maps until 5. You can use K-maps forever afterward, like from this point on, but for 4 you still got to use the Boolean algebra.
Oh, for 5 as well.
Now you might use a K-map for assignment 4. Now that you know how to do K-maps, it'd be pretty good to use K-maps for what? To check your stuff, right? It'd be pretty good to like, well, what is the minimum solution for this using a K-map? And then that way you kind of know where you're trying to go when you're doing the Boolean algebra. So I might still use K-maps as a helpful tool to complete assignment 4. As far as showing your work and making Max happy, you gotta do the Boolean algebra.
Do we have to simplify every solution as much as possible, or only when it asks for the simplest solution?
Only when it asks for a simplified solution. Yeah, the question doesn't ask you to simplify, don't simplify. All right, I'm going to change it up just a little bit for this last example. Up till now, we've been finding the minimum sum of products form, which is the thing that we like, this thing that we use most of the time. For this last example, I want to find the minimum product of sums of, I'm still going to give it to you in, so it's an F, A, B, C, D is equal to the sum of min terms, 0, 2, 3, 4, 8, 10, 11, and 15. So we're going to populate the map in exactly the same way. We're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the map is set up the same way, but now we're looking for a product of some solutions, which means we're going to group what? We're going to group the zeros now, instead of grouping the ones. Everything is exactly the same, except now we're just doing the zeros. And we're going to get product of sum solutions, as opposed to sum of product solutions. And there's also one last quirk that we'll talk about here when we do one. So, who's got a group of zeros from?
1, 5, 13, and 9.
Yeah, when it jumps out, 1, 5, 13, and 9. So what is that going to get us? Not quite.
C not or D.
What's that?
C not or D.
Okay, so we started with
Oh.
C not D. So the row, you're absolutely right. The row is the C not D row. We're to the zeros, which means it's going to be what?
Oh, C D not.
It's going to be C
D not.
or D not, yeah.
What is that?
Remember, so it's going to be, let me do it over here. So that row is the C naught and D row, but since it's a 0, I got to take the inverse of it, right? And Morgan's theorem says that that's going to become C or D naught. That's the hardest part of doing the product of sums, is like remembering, oh yeah, I got to do the inverses of everything. So, what else we got?
Can we do 12 and 14?
12 and 14. 12 and 14? Yeah, you bet, 12 and 14. So let's see, so that's going to be here and there. And what's that going to get us? If you're still having trouble kind of like
A naught or B naught or D.
good. So you're absolutely right. As I was about to say, if you're still like a little bit unsure, you can always just kind of devolve or revert back to the old way, which is under sum of products, this would have been what? It would have been A, B, D naught, right? And from De Morgan's theorem, that's going to be A naught or B naught or D. So if you're still not quite comfortable doing it in your head like that, just write out what it would have been and then take the inverse. So yeah, so that's going to get us A naught or B naught or D. No.
7 and 6.
7, 6, good. And that'll give us what?
A or B naught or C naught.
Good. It was A or, once you do a double, it's pretty easy to do in your head, I think. Or C naught. And there we go. That's our minimum product of sums. I said sum of products again.
For sum number 5,
What's that?
do you Boolean algebra? Or, I'm sorry. Do we see Boolean, or do we have to use this at all times? Or can we use both?
Officially you gotta use this, right? Chapter 5 is about
Yeah.
this, right? So you gotta use that. I don't know, I've never known anyone who was like, yeah, I'd rather do the Boolean algebra than do K-map. You can do both, but for the problems they're gonna say, use a such and such variable K-map to solve this, right? Now if you are feeling really confident, feeling good about your Boolean algebra, absolutely do the Boolean algebra to sort of check your stuff. I always use, when I'm done, I'll kind of look at the thing and take a moment to say, could I use Boolean algebra to fix this a little bit more? But in, just like a sort of self-check. But no, the problems will be specific. They'll say use the K-map to solve the problem. Yeah.
Isn't it all topic, like for the test, is it over?
One through 5.
1 through 5?
Yeah, so there's a question involving 4 variable maps on the test. It's the last question on the test. Yeah.
So on the test, are we allowed to use K-maps, or is it going to?
The problem is specifically stated.
Oh, okay.
If I want you to use K-map, it's going to say use K-map.
Okay.
If I want you to use Boolean algebra, it's going to say use Boolean algebra.
But we can check with the K-map.
But you should definitely check with K-map, yeah. All right. That's actually all we have. Yeah, what's up?
What's the format for the take-home test?
Exactly the same as the self-study assignment. It's a PDF on Blackboard. You're going to get it. You're going to do the stuff. You're going to scan it in.
It's just a self-study assignment, but we're
Basically, yeah.
making it more fancy.
Yeah. Make it work. I mean, on this one, I won't even say like the questions are harder. I try to like maybe combine some things into one question. So you have to think a little bit more critically on the questions, right? And actually sort of apply what you've learned to solving some stuff. For some things, like there's not a lot you can do, right? A base conversion is a base conversion. There's not a lot of interesting ways to write, convert a number in this base to a number in this base.
Yeah.
But yeah, some questions won't be as obvious what I'm asking you to do. So you have to stop and think about, well, what is this asking me to do? What have I learned? And how can I apply what I learned to this? But again, it's a take-home exam. You got 3 days to do it, so. And it's much, much shorter than any of the self-study assignments have been. Cool? All right, any other questions about this, about the test, about anything? All right, in that case, that's all I've got for you guys today. Well, we're done 9 minutes early, so cool. I'll see you guys on, well, hold on, what's that?
So this isn't about like the lecture, this is just kind of like a run. Could you, I know we're not.
Here, hold on, I can't hear because you guys are doing things.
I know we're not doing 5 variable K-maps, but could you do like a 6 variable K-map where you have 3 variables on each branch and then have it an 8 by 8?
Okay, so a 5 variable map is 2 4 variable maps like lifted like on top of each other. I've heard you. I don't know. I've never thought about drawing. I know that higher order K-maps exist, but usually they're solved as like computers do it, right? So you can write an n-dimensional array to represent your like 10 variable K-map and then solve the K-map. But as far as drawing it by hand, I've never seen anyone go past 5.
Okay.
So yeah. So I don't know. Now I'm curious. I'm gonna look it up when I get back to office.
Can you upload the answers for the homework so we can study for the exam?
Yes, I will upload all the ones. My policy for that is I don't post the solutions until after that the penalty period is passed. So after 5 days past the due date, which I believe makes 1, 2, and 3 fair game. So I should post 3. I think I've already posted 1 and 2. So 5 won't get posted before the exam, obviously because it's due at the same time as the exam. So, and 4, I might post 4 a little bit early, just so you guys have that.
You just post 4 tonight.
What's that?
Post 4 tonight.
Post 4 tonight. I should post 4 tonight, huh? At like,
Oh,
yeah.
that's not bad.
You know what I'll do? I'll post 4 at like
11:50.
11:55.
I'm down for that.
You know, they still do that because then you copy all the stuff.
I can argue really fast.
Or you can say, screw it, like I'll get this and like take my 10-point hit, right?
Yeah, pretty much. I had a question. Do you know, sir? Do you have time?
Yeah, give me a second. Let me finish. Let me stop this.